In a previous lesson, I talked about using a design pattern called dependency injection, which allowed me to change the direction of dependencies for a particular class. Specifically, I wanted to decouple the domain layer's dependencies on the persistence layer because while I needed the services of some implementation of the persistence layer, I didn't want to be coupled to a specific implementation of the persistence layer. Today, my persistence layer may utilize SQL Server, but tomorrow I may want to utilize Azure Tables and Blobs. So I said I planned on using a pattern called dependency injection. To utilize this pattern, I would first add a layer of indirection, or rather a layer of abstraction, a C# interface. This would be a contract. The domain layer needs certain services from whatever implementation of the persistence layer might serve it. So the domain layer would dictate the method signatures through the use of this C# interface, through this contract. So the domain layer, in essence, is saying, hey, I'm willing to work with any persistence layer as long as it abides by the terms and the conditions as laid out in my contract. This is the contract, this C# interface. If you want to work with me, you have to implement these methods, including these input parameters and these return value types. All right. So now both the domain layer and the persistence layer depend on an abstraction, but the control is inverted, or rather it's reversed. No longer must the domain layer create new instances of concrete classes in the persistence layer, thus forevermore tying it to a specific instance of the persistence layer. Now we've broken that dependency. It merely depends on an abstraction, the C# interface that sits in between the two. The persistence layer now depends, or rather it implements the abstraction, the C# interface. So at runtime, some third party can inject an instance of the persistence layer into the domain layer dynamically. All right. So what I want to do in this lesson is talk about a couple of crucial considerations when talking about this idea, this pattern called dependency injection. And there's a lot of terminology, and there's a mind-bending change required in our thinking in order for us to take advantage of this in our applications. But the payoff is huge. Really understanding dependency injection and applying it will help make the classes across layered boundaries decoupled. All right? And so there are two big principles at play. The first one is dependency inversion principle. That principle states that high-level modules should not depend on low-level modules. Both should depend on abstractions, all right? And then secondly, abstractions should not depend upon details. Details should depend upon abstractions. So this principle inverts the way that some people may think about object-oriented design. Both high and low-level objects depend on the same abstraction. And by high and low level, we mean their position in that layer diagram, all right? So this principle is the basis for many patterns like the adapter pattern, the service locator pattern, the plugin pattern. These are all Gang of Four patterns, the original design patterns that were laid forth in a famous book from the mid-90s. However, dependency injection is the pattern that we'll find ourselves using most often, at least in the .NET world. The other principle is called inversion of control. It's a very generalized term or principle that originally referred to a style of coding where a framework controls the flow of the program. But increasingly, people began to associate inversion of control with the idea of dependency injection, where some framework, what we'll call a third-party injector or a third-party provider, or a third-party container, controls the flow of the program and determines which objects should be created and where they should be passed. So this leads us to the pattern that's called dependency injection, which is a more specialized embodiment of both of those principles. Dependency injection is a design pattern that defines three roles. There is a consumer that depends on other collaborating classes to perform a given duty. Then there's a declaration of that consumer's dependencies in the form of a contract, or rather what we were calling a C# interface. And then finally, there's some third-party injector, and I use the term provider and container as well, but some third-party software that will create instances of classes based on the contract and passes those concrete instances to the consumer so that it can fulfill its duties. All right? So, hey, I won't blame you if you confuse the terminology and if you don't get all of these ideas down because they're so similar in nature. I would just stick with the phrase dependency injection and get a sense of what we're attempting to accomplish and what it actually does. And then after you practice this more and more, you'll begin to see the nuances. All right? So let's talk about a few specifics. I've mentioned this third-party injector. I've also called it a third-party container or provider. What exactly is it? Well, it's officially known as a dependency injection container or DI container. And there's probably about 24 of these DI containers that are available via open source. And probably about 5 or 6 of them are really popular that people are using quite a bit. The ones I hear about most often are Unity from Microsoft. Their Patterns and Practices group created this and support it. There's also something called Castle Windsor, which seems to be pretty popular among those in the know. Ninject, which is my personal favorite. There's also AutoFac and Structure Map, and there are others. I haven't used most of these, but I hope to soon, and we'll create a series where we get to flex our muscles and try each of these out, take them for a short spin. There's also what is known as a poor man's dependency injection container or DI container, which is really just a fancy way of saying that you create the instances of the objects, that you write this injector that will create instances of objects and inject them at runtime instead of using some other third-party library or framework for this purpose. So for simple needs, I just create I create a poor man's DI container. I forgo using one of the larger frameworks because I'm not convinced I really need all the features that they offer. But still, I want to be familiar with doing it one way or the other. So how do these DI containers just automatically know which classes to create instance of? Well, the fact is that they don't just automatically know. You as the developer have to configure these tools in order to pass the correct instance of a class to the consumer class whenever it needs an implementation of a given interface. You say each time you see this interface, whatever it is, pass in an instance of this class. So in some DI containers, you configure this in an external configuration file, like an XML file. In some, you do this writing C# code to create these mappings. Whenever you see this interface, create and pass me an instance of this class. And so now, anywhere in your application where you see that interface, you'll get an instance of that class. When you create your dependent consumer classes, how do you actually allow a concrete implementation of an interface to be injected into it? So how do you modify your consumer classes to allow for injection? Well, there's actually several different ways to do this. The most popular way is through constructor injection. So take a look at this class on screen. Here we see a order entry class, and you'll notice that in the constructor it takes an instance of iOrder repository, and then in the body of that constructor it saves off that instance to a local private read-only field. And whenever it needs to get to the order repository, then it'll be able to get back to it. So the order entry class in this case is just a simple domain layer class that I've created, and it's fictitious at this point. It needs a repository or it needs services which it depends on for the purpose of persistence. The term repository is an implementation of a design pattern called repository. It sounds complex, but it's simply just a class that knows how to perform basic create, read, update, delete actions specifically related to, in this case, orders and order items and so forth. So if you take a look at the constructor again, like I just pointed out, notice that it accepts an instance of iOrder repository. It then keeps that private reference to the concrete implementation of the iOrder repository interface. So whenever the application or whenever this class needs a service that's defined in the iOrder repository interface, it can use that private _order repository object to call methods that it needs. All right, so this is an example of the constructor injection pattern. There are other patterns like a property injection pattern that could be used, but I typically inject dependent classes in the constructor. All right, so we already know that a dependency injection container would be responsible for creating an instance of a class that implements the iOrder repository in this particular example that I've been using. What you might wonder is when this mapping should happen. Where should you configure the DI container in your code? Where does it all get kicked off? Which layer should be delegated this responsibility? Well, I found a great answer from this book. It is Dependency Injection in .NET by Mark Seaman, perhaps one of my favorite books on programming. It's just on the topic of dependency injection, obviously. It really helped clear some things up for me. And he basically says that this sort of mapping, this setup, should happen in the composition root of the application, which is basically a unique location in the application where modules are composed together, which is essentially what we're doing. We're composing modules. We're saying, hey, we want to dynamically, whenever you see this interface, compose that with this concrete instance of that interface for this application. And he says that that should happen as close as possible to the application's entry point. And so it really depends on the type of application that you're building. So for example, if you're building a console application, then you would create that mapping in the main method. If you're working in an ASP.NET MVC application, then you might do it in the global.asax file. In a WPF application, it's going to be on the application.onStartup method. And in a WCF, Windows Communication Foundation web service layer, it would happen in a custom service host factory. And so in his book, he provides some examples of these. The other interesting side effect of using a dependency injection container is that you'll wind up using the new keyword quite a bit less than you would otherwise. In fact, some say the new keyword is problematic because when you use the new keyword, you're coupling one class to another. I've even seen the slogan, "No news is good news." You get it? It's pretty clever, right? I'm not convinced that having an entire application void of the new keyword is such a great idea. That means that you inject every dependency every single time, and to me, that doesn't make a whole lot of sense. It just complicates the design. I tend to think that dependency injection makes sense, most sense where layers meet, not necessarily inside of a given layer. So whenever you need to break dependencies, dependency injection is great, but you don't need to break every single dependency inside of an application. At least I don't think so. You don't need to make it completely decoupled. It's okay to have some coupling, especially inside of a given layer when there's no need for to introduce a seam into the application to allow for different implementations, right? But let's suppose for a moment that I wanted to provide alternate implementations of a given service for a dependent class. For example, I might need a different tax class, each of which implements a different tax rules depending on the shipping address of an order. So how can I determine which tax class is the correct one to create an instance of so I can give the right one to the order class? That's the realm of a different design pattern. I'd probably restructure things a bit and use the strategy pattern. So different countries or states would be associated with a tax class implementation. So when the order object needs to apply tax to an order, it would rely on the shipping address object's associated tax object. The beauty of this approach is that I don't have to create some massive if-then-else statement or some massive switch statement to create an instance of the right tax class given my specific country or state within a country, all right? To me, whenever you see these large case select statements or these large if-then-else statements to determine which object to pass in, that's a smelly solution because you'd have to modify that code each and every time you wanted to add a new shipping country or state, and that list could get really, really long. So again, I realize you might need to see all of this in action so you can see it all come together. And we're going to do that in the second part of this series when we actually apply these ideas to a real problem. But to recap this lesson, dependency injection is just like every other design pattern. It's an elegant solution to a common problem. We want to decouple our concerns and by doing so, keep our applications flexible, the opposite of brittle. With dependency injection, you're able to keep layers and therefore concerns separated. So in the next lesson, we're going to talk about concerns that cut across all the layers of our application, and we'll talk about how to address them in your application's architecture. We'll see you there. Thank you.